Hi, welcome to the TechHub.training solution video for the final challenge in the Pandas Python Learning Path document. As always, we encourage you to try and find your own solution to the challenge before watching this video so that it is more beneficial to your learning. However, if you have been trying and you're getting stuck, or if you found your solution and just want to compare, then hopefully this video will be of use to you. After you find a solution, we also encourage you to reply to the challenge with your solution so that you can contribute to our growing community. So opening up the Jupyter notebook that is given to you, this is the solution document that I created. One thing to keep in mind is it is highly likely that your solution will not perfectly match with what I created, and that's okay. The versatility of Python means that there are many ways to reach the same endpoint with different means of getting there. So as long as you reach that endpoint, then it's all well and good, although sometimes you should be making sure you're using the most efficient ways or not using the wrong functions, or in this case, trying to apply the principles you're learning in the learning path document. So before we actually get into this solution, remember, well, let's go over the scenario first. You're an accounting intern for Slice and Dice Megacorp, a newly formed yet large-scale tech corporation. The accounting department has been in shambles because this large-scale corporation came as a result of a merger, and each of the different companies that went into that merger had their own accounting methods, and because of that, they all had their own ways of keeping their books, and it was a mess getting them all into a consolidated file. And so you're going to be asked to do different things with this data, because thankfully they were able to consolidate it into this one Excel workbook, but all in different sheets. Now, before we really begin, it's important for you to understand when doing both these learning path challenges and challenges on the website, and when you get further into your career, two things. First, you need to understand the instructions you're being given. Of course, you need to know what the end goal is of what you're doing, otherwise you might be working towards something that doesn't have any sort of value, and it's not what your manager or client are looking for. So of course that is a very important thing to understand. But second is you need to understand what data you are working with to reach those solutions. And so if you open up this provided Excel sheet, you will see all of these different sheets that are in there. And if you read the first step, it says read each quarter into separate data frames. Okay, maybe you know how to use the pd.read Excel function and can read in the actual Excel file, but if you don't know what the sheet names are that you are putting in to your different data frames from the Excel book, then you won't be able to actually read in that information. And so I encourage you, if you haven't, to look through the Excel workbook so that you know kind of the data that you're working with. So now actually getting into the Python coding, first you are asked to import this cell is provided for you, and so you should run it so that pandas is imported and your displays are nice and pretty and understandable. But the first thing you're asked to do is read in each of the 4 sales data quarters into their own data frames and then put them into a single data frame afterwards. So again, understanding your data, you have each of these sales data quarters and you're going to read them into their different data frames, and then you're also instructed to make sure the date column is a datetime object. which is done by this parse date functions on the date column. Next, you're going to put that data list, you're going to create a data list of those 4 data frames so that afterwards you can run the pd.concat function into data. This ignore index parameter is important because you have these 4 different sales data quarters and they share indices between each other, at least as far as they match. So sales data Q1, this second row has index 0 in that data frame, and then Q2, the same thing, that's index 0. And so if you read it in, then there's a chance, high probability, that the matching indices will conflict with each other and cause some problems. So quarter 3, for example, has 3722 records, and quarter 4 has 4408. So there's around 700 that won't match up on their indices, which is fine, but it's all of those ones that do match that you want to avoid the problems for. So that's why we throw in this ignore index parameter. Afterwards, you are going to read in customer, product, and salesperson from their respective sheet names. Moving on to part 2, you are going to be asked to manipulate and analyze the data, and our first goal is to merge everything into a single data frame instead of having them in these 4 different data frames separately. So you're going to use pd.merge. You're going to name both of the different data frames that you want to merge. You're going to signify on, and these are going to match in this case. So if we go up here and look at data.head, we have customer ID, and if we run customer.head, then we can see that it also has customer ID, and you can also see that by looking at your data. So if you go to the top, customer ID here on the sales data, customer ID. Again, understanding your data is important. So you're going to say on which column they're going to match on and merge. How, in this case I use outer so that you can see how the underscore merge column is behaving. And this indicator parameter is the one that creates that underscore merge column. Next, you're going to do data missing is the data where underscore merge is equal to write only. So that means when you're inputting your data here on the merge, anything that's only in the customer data frame will be identified with write only. Anything that's in data frame will say left only. Anything that's in both will say both. And so that's what this indicator does. It tells you which table or which data frame the contents of that row are coming from. And so this is another option. If you didn't use this indicator, you can say just where it says write only, and then your filter would be where it says NA. Dot is NA. So that's where you see all of these. These are null values. And so if there are null values on the columns that come from your data frame, then that means it is only from the right data frame, which is customer. And so if you are using the indicator, and this is given in the hints, you have to make sure that this underscore merge column is deleted because we're going to be using other merges, and each time you use it, if you tried to use this indicator's true twice, I'll just show you, then it would not be able to run because that indicator column is still there. And so we're going to make sure that delete data underscore merge is there so that we can continue using those. If you do end up doing that, then you're going to need to rerun your first cell so that this data frame is recreated, and then you can run this one again. And you can do that for almost any error that arises that's similar to that about the indicator column. You might notice that every step we are updating this data variable instead of creating a new variable, and that both saves memory space in creating our data frame and in our environment, and second, we're going to be using this merged version of data later on in the analysis in this challenge. So we can print out the number of customers who did not make a purchase using an F string here. And so data missing, we assigned that, and customer ID. So we know the number of customers who did not make a purchase is 4. And the customer type is here, and they have pretty comical names. Okay, part 2. It's pretty similar. We're doing a similar join between data and product. So this time the only difference is, of course, the two tables we're merging and then how we're merging them. We want to say left because we're going to make sure we keep all of these records from data, and we're not really concerned about the product table, and which items in it are not returned or do not match with any sales data, because maybe there are products that exist that were never sold, and that's fine. So we just want to make sure that any data that can be matched in the product table is matched to those sales. And again, we're going to include that indicator to make sure, because there are evidently products that do not have a name but do exist in the sales. And we see this in the product ID is 103. So when we get to 2b, it asks, there's a product ID that does not have a matching product name, creating null values here in the merge set. Identify yourself what this product ID is, and we just did that by looking at 103. And then we can use the .fillNA method to fill in the null values within the original data frame's product column. And so we can say data product now equals data, that same column, we're updating product dot fill in a with the name of the product that is missing, which is given here, mini server C3. So if we were to run this again, then, and just said the data where data dot product ID is equal to 103. No, I forgot a closing bracket. Sorry, don't want that. I didn't run this earlier, or this one. Now we can see that, oops, sorry, there. Now we can see after running that each of these 103s have been given the mini server C3 product, which was not the case up here. Okay, moving on. On to number 3. You're asked to create a function, because if you look at the commission rate in the original salesperson data, you will see that the commission rate is written in as a string. So 3%, 4%. We want to be able to capture just this right here, this first number that appears, and so that we can use it in a calculation. And so you can do that by first defining your function, which you should have learned in a previous learning path, how to create functions. And then the parameter is a string, which we know because we just looked at it in the salesperson data frame. So string, we're going to split it because it has that single space in the default split parameter is a space, and then we can assign the new variable to string, which we just split, 0. So if we broke it down, then we would have a list that said 3 as the first item for, let's just go look at it, 3%. This would be split into two things, 3 as the first item in the list, and then percent as the second item in the list. And so we can take that first item in the list, which is 3, and then multiply that by 0.01 after making sure it's a float. And the reason we want to do that first item is because, and do that split, is because there might be a percent with a decimal, and we don't want to just keep it as a string and grab the very first item, because then we would ignore this 0.5 in later records. And so we'll split it and then float it and multiply it by 0.01 to get a percentage. And we can see that being returned here in the commission rate. After that, we want to make sure that we apply it, and that's how it comes out. Because making the function isn't enough, we actually need to apply it. So we can update that column by saying, here's that same column, apply, and the parameter for the apply function is convert string, which is that function we just made. Okay, next we actually want to use that converted column that we just made that changed from string to a float. So what we're going to do is merge like we did previously, this time using the salesperson data frame and the salesperson ID column, again keeping all of the records that are in the sales data, not necessarily anyone who didn't make any sales. Then we're going to create a new column called commission, and that commission column is a result of data commission rate, which we just created in that merge and added it to data, and then multiply it by sales. So we can see that the commission rate here multiplied by the sales is around almost $1,400. And then again, remember to delete the merge. So now that we have everything into a single data frame, we can begin to analyze the data that's in there. So now let's create a data frame called salesperson transactions, and we're going to count the total number of sales that were made by salesperson. And so we can do that because this salesperson column is now in this full data set. So we're going to say data.salesperson. So this column, it's the same as calling a column by its brackets. It's just a different sort of notation. And then dot value counts, that tells you how many records are associated with each salesperson. And then we're going to reset index. And the reason we do that is because we want to make sure that in this case, salesperson is its own column and it's not the index of the rows. And so we can see that Raul Carrillo is the head salesperson for the year in terms of total transactions. Next, we are asked to find the total dollar value of sales made, and we could look at this for the whole year, but instead we're just going to look at the total for November. And so first we're going to use this .dt.month function so that we are able to pull from that date time object that you did in the very beginning and assign it to a new column called month. So what that does is, if you could just look at that in isolation. Did I not run these again? If we ran this in isolation and we didn't change anything, then we could look at the data and say data.head. And you would see that the month is pulled in from this date. So we know that this is the first month, so January, and this is the fourth month, represented by 4 there. So that is what the .dt.month method does for you. So what we're going to do is November sales equals data.groupBy function, and you can say which columns you're grouping by and in what order. So salesperson, then month, and if we ran that, we would see all of the sales people grouped by each of the months that they sold in different columns, and then we can say here what methods we want to run. So sales is what our total is going to be. So it's grouped by these two, and then the aggregate functions are going to be performed on sales. We're going to reset index again, similar to what we did up here. And then we're going to make sure that it's actually just November sales by searching for this month equals 11, which is the number value of November, and then sort the values by sales. And so that will produce this table. And we can see the highest selling salesperson for November was Raul Carrillo again. And it's interesting to look at just because Raul was the highest seller in both, but if you look below, Maria Garcia in total had less sales than Joan Townsend by only around 47 or 67, but here she had over $1 million more dollar totals in sales. So it's an interesting perspective that you get. And I wanted to run these as well so that the columns are cleaner. You don't see this month column that was here. If this delete November sales month wasn't there, then you would be able to, you wouldn't see only these 2 columns. Finally, we're going to find the median sales amount for each month. And so similar to what we did in the last one, we can create a month column using the .dt.month function. We can create a monthly sales, which is grouped by month, and then again sales, except this time looking for the median as our aggregate function, and display what our median sales is for February. And that's it. Hopefully this video helped and it guided you towards finding your solution. And we hope that this learning path has been great for facilitating your understanding and you feel like you're more prepared for tackling other challenges on our website. Thank you.